Hi, this is R. Janathan. Today we are learning about the addressing modes in DPCO. What are addressing modes? Definition. An addressing mode specifies how the CPU identifies the operand for each instruction, whether it's embedded in the instructions itself, stored in a register, or located somewhere in memory. Type of addressing modes: immediate, direct, indirect, register, indirect, indexed, base register. Immediate. Data is part of the instructions itself. Direct. Address given explicitly in instructions. Indirect. Address point to another address. Register. Data lives inside a CPU register. Register indirect. Registers holds memory address. Indeed, indexed. Base plus index for array navigations. Base register. Base plus offset for reallocation. Immediate and direct addressing. Immediate mode. Data is embedded in the instructions. The operand value is a part of instructions word itself. No memory access needed. The faster mode of all MOV A, 5. A receiver that literal value 5 instantly. Direct mode. Explicit memory addresses in instructions. The instructions carries the actual memory address where the data resides. One memory access request. Move A, parenthesis 100. CPU reads from memory locations thousands. Indirect and register addressing. Indirect mode. The register are instructions holds an address that points to another address. The CPU follows the pointer to reach the actual data. Powerful but requires two memory access. MOV A, R1. R1 contains the address. CPU fetches data from the address. Register mode. The operand is stored direct inside a CPU register. Lightning fast, no memory involved, idle for frequently used variables. Move A, B. Data moves from register B to A register. Register indirect indexed addressing. Let I show the diagram. If you not understanding, kindly to see that. Register indirect. The CPU uses the value inside a register as the memory address. Similar to indirect but faster. Only one memory access needed. Idle for dynamic pointer manipulation. Indexed addressing. Effective address equal to base plus index register. The index increments automatically make it perfect for traversing array and the data tables in loops. Base registers are addressing. How it's work? Effectively address equal to base register sum of offset. The base register stores the starting point. The offset navigates within a segment. Memory reallocations. When a program moves in memory only the base register updates. All instructions remains unchanged. Essential for OS multitasking. Key advantage. Enables versions independent code allowing programming to run at any memory location without recombination. Real world uses for addressing modes. Array and loops. In indexed addressing iterates through array elements efficiently. The index auto increments each cycle. Pointers. Indirect addressing pointers operations in C++ enable dynamically memory access at runtime. Operating system. Base register addressing enables OS memory segmentations, process isolations and safe multitasking. Embedded systems. Immediate and register modes. Dominant embedded code speed and minimal memory footprint are critical. Advantages versus limitations. Advantages. What are advantages contains in it? Speed. Register and immediate modes execute without a memory delays. Code efficiency. Shorter, more compact instruction sets, flexibility, different modes, suite, different data access patterns, scalability, indexed and base register modes scales across large data structures. Limitations, complexity, indirect modes requires multiple memory access, increase latency. Register scarcity. CPU have a limited number of registers. Heavily reliance can create bottlenecks. Debugging difficulty. Indirect and indexed addressing make program tracing harder. Hardware cost. More modes requires more complex CPU decode logic. Conclusion, addressing modes are the backbones of CPU instruction designs. The choosing the right mode means the difference between splurge and blazing fast executions. Performance, right mode, faster fetch cycles. Flexibility supports arrays, pointers, and OS task. Relevance, core knowledge for cybersecurity engineering. Thank you.